So the limit that we're given here is neither a power function or exponent function. It has an x on the base as well as a numerator. Okay. Whenever that happens, what you want to do is ln both sides, ln this expression so that all the x's come down, and we don't have this complicated expression of x to the power of x. So first let's let y equal to pi over 2 minus arc tan x to the power of 1 over ln of x. Ln both sides. And log has this property. If you have log of a to the power of c, it's equivalent to c times log of a. So that means we can bring that down to the front. And when we do that, we get 1 over, actually, let me write it this way. So all over ln of x. Okay, so let's see what happens as x approaches to infinity now. Now, as x approaches to infinity, from the numerator we have arctan is approaching pi over 2. Then we have pi over 2 minus arctan x is approaching 0 from the positive side, which means we have ln of that same thing inside will approach minus infinity. Okay, so make sure you can follow that. And at the bottom we have, of course, ln of x is going to approach infinity as x approaches infinity. So I've just shown that the top and bottom, it's as x approaches to infinity, it's an infinity, minus infinity over infinity case. So we can use L'Hopital's law, right? L'Hopital's rule to find this limit. So that right there, using L'Hopital's rule, is equal to, when we're doing limit, to the following. Differentiate the top and we get you get 0 minus 1 over 1 plus x squared on the top. And at the bottom, you just get 1 over x. Okay. So let's simplify that. And we get, if you multiply by x, we get x, or minus x, all over pi over 2 minus arctan times by 1 over 1 plus x squared. Oh, sorry, I made a mistake there. It's not 1 over 1 over x squared. It's just 1 plus x squared at the bottom here. Okay, unfortunately, this form here still doesn't give us a determinable limit. So we need to manipulate and perhaps use L'Hopital's one more time. So what I'm going to do is bring this to the top. This way, minus x over 1 plus x squared all over pi over 2 minus arctan x. Now as x approaches to infinity, the denominator is approaching 0 for the same reason I gave above. Right, so pi over 2 minus arctan x is approaching 0. Now as x approaches infinity, this expression here is also going to approach 0. Okay, because of the degree of the bottom is higher. Now we have another form which you can use L'Hopital's rule, sorry, and let's do that. So the top will be quotient rule. So you differentiate the top, you get minus 1 plus x squared, minus, leave the top alone, and differentiate the bottom, you get 2x, all over 1 plus x to the power of 4. The bottom you get 0 minus 1 over 1 plus, sorry, made a mistake there. It's 1 plus x squared, right? At the bottom you get 0 minus 1 over 1 plus x squared. Okay, so it looks complicated. Let's carefully clean this up. We have minus 1 minus x squared minus minus will give you positive 2x squared all over 1 plus x squared squared, and this minus 1 over x squared, same thing as times by negative of 1 plus x squared. So that'll reduce with that one, and this negative we can put it at the front and multiply it into the top. Let me continue up here. I have minus 1 plus x squared all over 1 plus x squared times by negative 1. Okay, so now we're on to something. 1 minus x squared, if you multiply negative 1 onto the top. If you apply the limit, divide top and bottom by x squared, and we get 1 over x squared minus 1, 1 over x squared plus 1. So as x approaches infinity, these two guys will approach 0. The whole limit is approaching negative 1. Okay, so we're not going to get, this is not going to be one of the answers, because what we just found is what ln of y is equal to, right? So the whole time we've been solving where is ln of y going. So we just finished determining that ln of y is approaching negative 1. That means y will be approaching e to the power of negative 1, which is 1 over e. Okay, that's why the answer is 1 over e.